Hello, scientists. Last week, we made straw rockets and learned that forces can make things move. A force is any push or pull that can cause an object to start moving or to change direction. Forces can also cause an object to speed up, slow down, or stop completely. Did you know that when you designed your straw rocket with a cone-shaped tip, that you were actually considering another force? Friction. Friction is a force that opposes the motion of one object moving past another. When you rub your hands together on a cold day, you're using friction. Friction slows things down and creates heat. All types of matter can cause friction, even air. Air resistance is a form of friction that slows down cars, trains, airplanes, and even rockets. Scientists design their shape to reduce friction from the air. This is called streamlining. You streamlined your straw rockets. In today's investigation, we're going to roll cars or any kind of rolling object to investigate how friction affects the distance that object rolls. To roll your object, you're going to create a ramp. Then you'll test how friction affects the distance your object rolls. To vary the amount of friction, you'll need to be able to move your ramp from one location to another. One location should have a smooth surface and the other should have a rough surface. You'll see this will affect the distance your object rolls. Let's see what I can find around the house to do this investigation. I'll be right back. These are the materials I found. I want to start with what I'm going to build the ramp with. And I thought maybe this box might make a good ramp. And I have tape here that will stand on end that will help to raise the end of my ramp. So I'm going to try that first. And I'm going to roll the ball off and see how that works. That is a pretty steep drop off and it makes the ball bounce. So I think I need something that's thinner for my ramp. How about a book maybe? That's pretty thin. The tape worked pretty well for raising the end of the ramp. Let's try this. Ooh, that's not bad. So the book will work, but I think I'll make my ramp just a little bit bigger. And I found this folded box. It's a little bigger than the book. Let me try that. Ooh, I think I'm going to use that for my ramp. Now, when you're looking for the best rolling object, I want you to find an object that rolls in a straight motion. Motions can be straight like an arrow being shot at a target, or circular like a merry-go-round, or up and down like a pogo stick, zigzag like skiing, side to side like dancing, and some motion is a combination of more than one type. Like a swing, when you're swinging, you're moving up and down as well as forward and back. Let's see which one of these objects rolls the straightest. The ball works pretty well. Try the potato. Oh. No, I don't think the potato is going to work. How about this? Oh, that one rolls crooked. Let's see. Oh, the car's not bad, although it kind of drifts to one side. And I've got a marble. Oh. I think I'm going to go between the ball and the marble. Let me test each one again. I think I like the weight of the marble better. So that's the one I'm going to use in my investigation. First, I'm going to take the ramp to a smooth, level surface, like a wood floor. I'll make sure that the ramp is at the same height. Then I'll test and measure the distance the marble rolls. I'm going to be using a measuring tape to measure the distance the marble rolls. If you don't have a measuring tape, Then you can estimate using a piece of notebook paper or even a dollar bill. A notebook piece of paper is approximately 8 inches wide. A dollar bill is about 6 inches long. After I've measured, I'm going to record my data in a table that looks like this. I'll do the same procedure for a rough, level surface like carpet. Now it's your turn. Gather your materials, perform the investigation, take measurements, and record this as your data. Pause the video now. Let's look back to the question we set out to investigate. Did friction affect the distance that your object rolled? Look at your measurement data. Did you find that the rougher surface measurements were shorter than the smoother surface measurements? Then you can conclude that rough surfaces usually have more friction than smooth surfaces. Did your investigation spark other kinds of questions about forces in motion? Maybe something else that you'd like to test? Till next week, stay curious and be safe.